Good morning, everyone. This is the spring session first spring session for IETF 110. Welcome. We will try to move expeditiously. I'm actually going to change the procedure on my co-chairs for a minute because I've just discovered, no, it's working. I thought I couldn't see the slides. We're going to kick off now with Notewell and the chair's introduction, and then we'll look forward to the various presentations. We will try to keep things moving along. We are very tight on time, even having compressed some things. So with that, we need the next slide on the chair slides, and a reminder to everyone that when you are presenting, you need to tell us when to flip to your next slide.
Joel, just as Jim, just a quick one. It's difficult for me to see. Can you see the slides okay? Are they covered on the screen correctly?
They're on the screen. We can see the slides and a little bit of the sidebar next to it, but unless somebody complains, this form should be fine for people.
Okay.
As you can see, this is the Notewell. I want to just leave it up here for a moment since this is the first session of the IETF 110. Notewell is important. It makes a big difference. Please pay attention to it. Please abide by it. You have to, but please. And thank you. Okay, next slide, Jim. This is our agenda for today. As you can see, it is very tight. We're starting with the status presentation I'm doing right now, and I'm trying to pick up the pace on that so that we get a few minutes back. We're going to then get presentations from the spring compression design team. We've allocated them 30 minutes total. First half to go over the current state of the requirements draft, which they seem to think is almost done, which is great. Thank you, finally. And then to talk about where they're going with the analysis draft, which at the moment is just a framework. We'll then be talking about the alternative marking method from Giuseppe. Zafar will be presenting about the OAM for service programming, and then how you will be presenting about the in situ OAM measurement. Following that, we have two presentations from Rakesh. While they are on individual drafts, this is getting very close to being adopted. So Rakesh, if you need more than 5 minutes for each, we'll deal with it. I mean, we're short of time in the rest of the session, but it's important you get the time to present. And in particular, if you use your, I mean, that's barely any time to present. You use your time, and we hope there's some discussion, because discussion is the point. We then have an individual presentation from Yakov Stein on segment routing time-sensitive networking. Interesting idea, new. I hope we have the time for it. And then the Yang data model for BGP segment routing. That'll be today. Let's hope we can get through it all. Next slide. The minutes are collaborative. There's the CodeMD pointer. Our secretary is primarily responsible, but she would very much appreciate any help that folks are willing to give. Raise your hand to get in the queue. If you're a presenter, you don't need to raise your hand. We'll tell you to start presenting, and you'll tell us when to page slides. But everybody else, raise your hand to put in the queue. We'll tell you when you can talk. When you can talk, unmute yourself. You can speak. We won't be unmuting you. You can unmute yourself. Please remember to mute yourself when we're done. We'll go through and do so if we have to, but it works much better if everybody mutes themselves. This is being recorded. This is the IETF 110. We are recording all sessions so that other people can see them later. It is also, as is obvious from your participation, being streamed. So it's all being sent. Thank you. Next slide. Leonard, did you want to say something right away? Thank you. We have some new working group documents that have been adopted for the VTN draft, which while it needs some work, it's now a working group document. It's the working group to decide how it moves forward. Thanks to the authors for all the work they've done so far and are continuing to do. And the IETF Spring SRv6 path segment, which has been adopted after some delay. Thank you. Next slide. We have the adoption calls on the two Gandhi drafts, Rajiv's drafts, going on. There was enough support to adopt them. If these were just spring drafts, we would have said adopted. However, these very much overlap with IPPM, and the core material is in IPPM, and they're still working out exactly what's going to happen. We will not adopt until IPPM has figured out what has happened. Unless what happens is a significant change of content, we will not need another adoption call. We will stick with the existing adoption call and just adopt what is appropriate when IPPM has determined the path forward. And that's part of why we're having Rajiv present today, because something based on this is extremely likely to be adopted by the working group, and we want the working group to know what it's working on. Next slide. Spring NSHSR is in working group last call. Bruno is running this last call because Jim and I were co-authors. I think right now I'm a contributor, but we're not going to make the call on it because it's our document. There wasn't enough review. Folks, we need your review. Please take a look at it. Get back to the working group list. If you like it, if you dislike it, if you think it needs improvements, whatever. But substantive comment would be really appreciated so that Bruno can appropriately call what the outcome of the last call is. Thank you. Next slide. 2 RFCs got approved by the IESG. One has been published. I'm the shepherd on both of these. 8986 on the network programming. My thanks to the authors. This was a very long slog. There were a lot of interesting and messy issues in the past. There were a number of interesting discussions with the IESG while I was shepherding this. The authors were really good about addressing the issues and then working with the RFC editor to get it done. It is done. Thank you. The Yang data model was approved by the IESG. It is now in front of the RFC editor. Given how responsive the editors were during the IESG approval, I expect again we will see a smooth sailing with the RFC editor, but I can't promise anything, but we hope to have it out soon. Thanks to the working group, thanks to the authors, and thanks to the working group for all your support on these documents. Next slide. And that's the end of this presentation. Jim, let's move to the next one. And Yangjing, Weijing, you're up. Thank you.
Hello, Charles, could you hear me?
Yes, we can. Thank you.
Okay, could I start?
You are up. Just tell Jim when to page to the next slide.
Yeah, so this is Wei Changcheng. I will present the slides on behalf of the design team. Next page. So here we list two main tasks running in design team. One is a requirement draft, and the other is analysis draft. The progress of the both draft is so far so good. We almost finished the work of the requirement draft and posted 05 revision. And we've started discussing the analysis draft and posted the 00 revision. We will take 2 slots to go through the both of them. Let's go to requirement draft and first, next page. Oh, so this is the analysis draft, right? No problem. Let's go through the analysis draft and first. So this draft will provide some analysis of proposed approaches to comprising segment routing information for use of IPv6. Here is a brief introduction of the analysis draft. The analysis draft, in fact, based on the basic input from the requirement draft. About 1 month ago, we solicited the proposals in Spring Working Group and 6-month working group for 2 weeks. Finally, we decided to analyze the
We seem to have lost your audio.
Yeah, and while we're at it, Joel, have I got the wrong slides here? Because he's going through the analysis, which...
That's what you're showing the analysis slides, Jim, but we can't hear Wei Ching all of a sudden.
No. Okay, it seems to have dropped off. Do we want to jump to
if he's
the topic?
fallen off
Oh, he's back.
completely,
He's just coming back. Wei Ching, can you? Yeah, sorry, we lost you there, Wei Ching. But let me interrupt for a second. Would you prefer me to jump to the requirement slides and then do the analysis, or are you happy to continue with the analysis? It seems I pulled up the wrong slides here, so I can jump to the other ones pretty quickly.
No problem. Let's go through the analysis draft directly. No problem, I think.
Okay. All right. So we're on the introduction slide. So please go ahead.
Yeah. So this page gives some introduction of the analysis draft, and I think we finally decided to analyze the following 4 proposals. The first one is CSID, I think, which is a combination of the GSID and microSID. And the second one is CRH. I think everyone knows that draft. And the third one is VSID. It defines a set of the SID behaviors to access a similar SID within the SR header. And the third one is UID. And I think it extends the SRH to carry such as MPLS libels or IPv6 addresses. Next page. So the following next 4 pages are provided by co-authors of those proposals respectively. And this page is for the CSID, which don't need any SR6 data plan or control plan change, and leverage the SR6 network program model. It provides 2 flavors. Next CSID flavor reflects the microSID, and the replace CSID flavor reflect GSID. Both of them are in the same framework. Next page. Yeah, this page is a brief introduction for CRH. CRH defined 2 new IPv6 routing header, CRH 16 and CRH 32. And each SID maps to a CRH fiber entry. There is no change to IPv6 forward plan or addressing model, and just a minimal change to SF6 control plan. Next page. Yeah, this page gives a brief introduction for VSID. I think VSID is a very interesting solution. It generates the SRH for any size of SIDs and prefix, and it builds on a common SF6 locator prefix. One SID is a combined prefix and VSID. Encodes only the VSID in SRH. I think everything else using the regular 128-bit set can be used as a similar solution. It does not require any SRv6 control plan change. And it also leverages the SRv6 network programming model. Next page. Yeah, this page is a brief introduction for UID. It's comprised SRv6 solution. It introduced.
Did we just lose Wei? We just lost Wei Ching again. Cheng Li, Wei Ching, you're back. Hello?
Hello? It used the UET flag to unify the traditional SRv6 set and unified set forwarding behavior, such as different code can represent IPv6 address, MPR sleeper, or IPv4 address. So next page. So the network is so bad. So sorry, maybe you lost me just now. Next page. Hello, Charles, could you hear me?
Yes, we can hear you.
We can hear you, and I'm on. I'm showing slide number 8.
The
I did not
SRv6
see
compression
any
scenario.
change in the screen.
He's showing the SRv6 compression scenario side.
This page give understand. Yeah, this page give basic scenarios. We hope analyze each solutions based on this figure. It consisting of 3 subdomains, and we will use this to analyze, such as the height size, the forwarding efficiency, and the state efficiency. Okay, next page. So this maybe you have a page up. So next page gives us some progress of this draft, and we started this draft from February, and now we have submit 00 version, which is a template for introduction and the format. And we hope to start the work on this draft after IETF meeting, and maybe in the middle of April, we hope to complete the remaining analyzed text proposal for design team review. And at the later April, we hope to post a preliminary version to working group. And at the later of May, we hope to submit a new revision for spring review. So that is a rough plan, and I hope we can catch up with the progress we promised. So that's all. Thank you. I think could I finish the next slides presentation, and then let's go to some comments or questions.
Yeah, that makes sense, Wei Ching, and I've got the slides showing now.
Okay, so this one is the requirement draft, and I think here next page. I did not see any change. So
it did change.
I suppose we are seeing the second page. So
Wei Ching, it's Jim here. So there's obviously a delay on your end. Just assume that when you say that change the slide, I've already done it and people can see it, and just continue.
Okay. So this page, I think we have already uploaded the 05 revision, and I think we hope to present the slides based on the latest version. So next page. And here is the latest. Here is the latest status of the requirements draft. In the 05 revision, we have included all the requirements we've received, and the design team have gone through all of them. And now only 3 of them with rough but not unanimous consensus within design team. So I think we almost finished the requirements draft in design team. We hope working group can review it and feedback the comments. So compared to the revision 2, this version moves 3 items. I think that is important items from appendix to the main text, which are blue highlighted. And we also added 9 items with red highlighted. We take a quick look at the next page. So next several page, we will talk about the items with consensus in design team. Next page. Yeah, so according to the comments in IETF 109, we clarified the goals of the design team. I think the first one is to identify solutions to SF6 seed proposals, to SR over IPv6 seed list comparison that are based on the SF6 standard. And the second one is to consider proposals that are not based on the SF6 data plan and the control plan. As such, this document includes the requirements to evaluate whether the comparison proposal provides all the functionality of SF6. So I did not, next page. Yeah, so this page is for SF6 based. I think we've presented in last IETF meeting. We just move it to the main text, and we get agreement on this point. I think that is a basic point. Next page.
Go ahead, Wei Ching. Heterogeneous seed lists.
Yeah, this is also from appendix to the main text. we've reviewed it last meeting. Next page. So this one is a new one. It's gives some requirement that the mechanism must not cause the loss of non-routing information when delivering a packet from SR ingress node to the egress SR node. In the next page, this page is for the addressing planning. So network operators require addressing planning flexibility. So the deployment by using GUA from a different address block. So this is for addressing planning. Next page. Yeah, for the compression levels, the compression proposal should be able to support multiple levels of compression. I think that is a basic requirement. Next page. So this is for the PS or BCP compliance. I think this is a very common requirement. We hope if it does not comply with any PS or BCP, it should cause to update the related document. I think definitely. So next page. Yeah, here is some security mechanism. So the compression solution should be able to address a security issue that introduces using existing security mechanisms. I think it's obvious requirement. Next page. So this page is about SR domain protection. Some operators raised this requirement. The compression solution must not require nodes outside the SR domain to know the state value within the SR domain. So it must provide the ability to block nodes outside SR domain from accessing seeds. So next page. Yeah, following three requirements with a rough but not unanimous consensus within design team. And we hope to get feedback in working group. Next page. Sorry, here maybe the title is wrong. It should be IPv6 based. It's a typo. So this requirement require every node along the packet's delivery path to be IPv6 capable. It must not require any node along the packet forwarding path to support any other forwarding plan, such as IPv6 or MPRs, something like that. Next page. Yeah, this one is about point to multi-point. In fact, the design team sent an email to working group to ask for some feedback. So this one, this item give a requirement that the compression mechanism should support P2MP SR pass. And in design team, we have not got the agreement on that, but most of members think it's reasonable. Next page. Next page is about the passability. This requirement hope the compression mechanism must be consumers the comprised seed list must be able to decode the active and the next segment. Passing information may be conveyed in either the forwarding or control plan. So I think this is also a very important requirement. So next page. Yeah.
So let's just take questions. We're out of time, and this is just a final. So let's just questions or comments. Please raise your hand. Put yourself in the queue. We'll recognize you quickly.
Yeah.
KR, go ahead. KR, you can ask your question. Please unmute yourself and you can speak.
This is Kayur from Arcus. Can you hear me?
Yes.
Super. I was in and out of the presentations during the analysis proposal. And the question is specifically on the analysis draft. I've noticed on the mailing list that there was an analysis for set of proposals that was done earlier. However, the comparative analysis has not been released in the draft. Is there a specific reason, or will that happen anytime soon?
Yeah. So thank you for your question. I think about 1 month ago, we sent an email to Spring Working Group and the 6-Mind group to call for the candidate proposals. And we did not get some more feedback for the proposals. And these 4 proposals are provided by the members in the working group. So this moment, we hope to analyze those 4 proposals in the analysis draft. If in the future there are some more proposals, I think we need to see how we can handle it. But if we will set some deadline for the candidate proposals, I think that deadline is February 12th. So this revision, we hope just analyze these 4. Thank you.
Okay, Andrew, go ahead.
Yeah. So I've got a simple question, and this is more aimed at chairs and the ADs. We're now sitting more than a year into this process. We're looking at further delays. In the meantime, multiple of the solutions that are being talked about here are shipping in active code, on spotted code points, etc. And the development is continuing. So what I want to know is, what is the actual way forward? When are we going to get some clarity? Because the longer this drags on, We know that these things are going to appear in routers, whether we like it or not. They're developed, they're out there, they're shipping. They're sitting on squatted code points at the moment. But if we go and continue a process that is going to take another year and another year and another year, we're going to be sitting in a situation where sooner or later, if these things ever do become RFCs, the code points change, that's bad for the consumer. That's bad for the industry. That's bad for the operators. So my question is, this is all well and good, but, and I've said it before, this stuff is going to continue with or without. So what is the process from here? Where do we go from here when nobody's stopping development? And now we've got stuff that, because of the delays and because of the war of attrition, is actually now shipping. So where to from here?
The chairs are aware of the time it's taking, and we are talking about ways to make things expeditiously, but the best thing we can do is we hope the design team will move expeditiously. And meanwhile, code points aren't under our purview at all. 6men, for example, is perfectly free to allocate CRH a code point right now, as far as we're concerned. We have no say in that. Okay, I don't think there's more we can say right now. The chairs do hear your point. We are not ignoring it. Thank you, Andrew. Chae Sung, go ahead.
Hi, can you hear me?
Yes, we can hear you. Go ahead.
Okay, thank you. Thank you, Weiqiang, for your presentation. It's not about the presentation contents, it's about the draft, because I just go through the analysis draft. I noticed there are a lot of empty tables in the documents, so I'm a little confused. What is the progress of this document and why these tables are still empty? Thank you.
I'm going to save him some time. That's because they said explicitly.
Yes, thank you very much for your
was...
question. I think the progress is that we have provided the template for the analysis draft, and we have decided to use the to analyze the 4 different proposals. I think that is a big progress. Of course, based on those tables, which now are black, but we will fill in those tables soon. So I think we are confident to deliver a full version of the draft on the later May. So thank you.
Okay, Boris, this is the last question. I'm cutting the line. So Boris.
Hi, thank you. So very short question about parsability requirement. Different vendors use different chips. So how it could be formalized in some unified way?
I think here we want to some basic requirement that doesn't related to some detailed implementation. That just give a basic functionality requirement. So the possibility here means through the forwarding layer or control plane, the packet can be passed no matter what mechanism you use. Thank you.
Okay, thank you. We need to move along now. Giuseppe, you're up. As you can see, Jim has your front slide up.
Hello, everybody. Can you hear me?
Okay, thank you.
Yes. Yes, we can hear you.
Okay, good. This is a new document on the application of alternate marking for segment routing with ticks. So next slide. Yeah, just a few words about the alternate marking method for whom is not familiar with this methodology. So it's a passive performance measurement technique that allows packet loss delay and delay variation measurement. There are two reference documents for this technique that are RFC 8321 and RFC 8889. So the methods basically consist of batching packets based on time interval to measure the loss, while you can use a second bit to select some new set of market packets for delay measurement. So yeah, it basically uses 2 bits to measure loss and delay variation. So next slide. Yeah, regarding the SRv6 application, this is the main scope of this draft. So for IPv6, we already have a document in standard track that has been published in 6 months that defines new option headers, both op by op and destination option to encode these marking bits in IPv6, in the IPv6 data plane. Regarding SRv6, as you know, as in general for IPv6, both op by op and destination option can be used when the SRv6 header is present. This is valid in general for any routing header. And in particular, if we are using destination options before the routing header, the option is processed by each destination in the route list. So by each destination and by each segment ID. So we already have a way to implement the alternate marking for SRv6 by using the destination option before the routing header. But this document aims to, let's say, discuss and define a new SRH TLV in which we can encode the alternate marking data. And in this regard, we would like to hear the feedback from the Spring Working Group in order to discuss if this is convenient to do that, or we can use the destination option together with the segment routing header. Maybe for SRv6, it may be preferred use of SRH TLV, but for IPv6 data plane in general, of course, op by op and destination option are the best choice. Next slide. The alternate marking data fields is the same that we have already defined in the IPv6 extension header. So we have 2 bits, the loss and delay bit in TLV, and the flow monitoring identification that I will explain in the next slide. It's important to say that the TLV is set by the source node that the data do not change en route, and the nodes that are not capable of supporting this TLV can simply ignore it. Next. Yeah, this slide explains why we need this identification field together with the 2 marking bits. This is due to implementation reason, because the use of flow monitoring identification helps to reduce the configuration for each node and also allows a flexible granularity in terms of flow definition. It simplifies also the counters handling and the data export. So these are important reasons why we can use this 20-bit flow monitoring identification. We already had some discussion in 6 months about the flow monitoring identification that there is also a chance of collision, because if it is set pseudo-randomly by the source node, there is a 50% chance of collision for just 1,200 flows. So in some cases, this can be a problem, but if this is not enough, you can increase the entropy by tagging with an additional flow information. Otherwise, in case of a centralized controller, the controller can set the flow monitor ID and then can consider all these aspects and instruct the nodes properly in order to avoid this ambiguity and to guarantee the uniqueness of the flow monitor identification. So next. Yeah, some words about how to use this TLV. As I said, the ingress node, if is capable to support the alt-mark TLV can set and both the flow monitor identification and the loss flag and deflag according to the alternate marking operation. The intermediate SR node and the egress node, if are capable to process this TLV, can simply read the bits and apply the alternate marking operations. While if an intermediate node or ingress node are not capable of processing the alternate marking TLV, can simply ignore it. It is worth noting that this is not an issue because if a node is not capable to support this TLV, the measurement can be done and can be done only for the supporting nodes that know that not support this TLV is just out of the measurement. Next. Okay. This is a straightforward way to apply the RFC 8321 and 8889 to SRv6. We welcome questions and comments from this draft, and thank you.
Okay, any questions? If I don't see one promptly, we're going to move along because we are short of time. Thank you, Giuseppe.
Yeah.
Okay. No, Jim, you're flipping through decks. I believe it was. We need the OAM for service programming right now, Zafar. You're on the queue. You may unmute yourself, Zafar, and you can start.
Yes, I'm muting myself. Can you hear me?
Yes, go ahead.
Excellent, excellent. So I'm going to present SRv6 or SR Service Programming O&M draft on behalf of my co-authors. Next slide, please. So this is a problem statement for the service programming and associated O&M for SR service programming. So here, a SID for the service programming is may be bound to a network function. A SID is just another network function. SID which is bound to a network function is just another type of segment. There could be two different type of SR service segments. Node number 2, as shown on this in this figure on left, is a type which is SR aware service. It is a service that is able to process SR packets, let's say for instance SRH, and it's aware of SRv6 endpoint processing and the pseudocode that is defined in the base SRv6 service programming draft. Then we have like node number 3, which are SR unaware services. SR unaware services are services that are instantiated on a router or host which is connected to a service node, where it hides or removes SRH before sending it to the service, and it works or it performs SRv6 functionality on behalf of the service. Another important point to see is that the SR service segments are fully integrated with VPN services or TE services. So when we talk about O&M needs to incorporate all of these comments, all of these functionality that SR service programming offers. In the next set of slides, we're going to go over that. Next slide, please. So we're going to basically do two types of a walk, O&M walk. One is when the UUT is node number 1, and we're trying to ping an SR aware service on node number 2. We call it function 1, or it's hosted at node number 2. So let's call it function 1 for simplicity. And The second function that we are going to do O&M functionality is on SR unaware service, which is node number 3. And so it's function 2. And then we're going to do an example where we take an integrated VPN with TE, and we are going to do a walk on O&M functionality to a VPN SID via a SID list. With that, let's move on. The next slide, please. So in this slide, we are at node number 1, which is the UUT. And this is an example of a ping to node number 2, which is an SR aware service. Since this service is SR aware, it processes the packet as per RFC 8986. Section 4.1.1 in that RFC says that if upper layer header processing is allowed, process the upper layer header. In this case, upper layer header could be UDP or ICMP, and the node 2 will process that and will send the response to the ping message. And that is the case for pinging an SR aware service where the service is ultimate segment. Next slide, please. Now, let's take a look at how SR aware service behave when it acts as a transit segment. Because some of the O&M payload may not be processed by the service or may be dropped by the service. So SR aware service should escape applying O&M payload from the service, but it should implement the end functionality so that the packet can be sent to the following segment endpoint. So in this example, node number 2, which is a transit SR aware service, skip the application of the service, but implement the end functionality and the packet, send the packet out towards node number 3. Next slide, please. Now we are pinging the service which is instantiated at 3, and the ultimate segment is SR unaware. We just, in the previous slide, we took the same example, but we went to the transit node where SR aware service was transit, and we said that it's going to skip the processing of the service and it's going to forward the packet toward the next endpoint. Now that endpoint is node number 3. So node number 3 received the packet with IPv6 set to its local service SID with ICMP or UDP payload as the next header. The SR service programming draft has pseudocode to handle that. If the next, and in this example, we're going to assume that the SID that is being pinged is a SRVC static proxy SID. And since the upper layer header for that SID is expected by IPv6, in this case, the upper layer header is ICMP or UDP. So then the service processes the upper layer header as per RFC 8986 section 1.1.1, which is if the upper layer header processing is allowed by local configuration, then it processes it and responds to the ping message. Next slide, please. Now we're going to take an example where an SR unaware service is a transit to a ping packet or O&M packet payload. In this example, we took the example where we are pinging a VPN SID advertised by node number 4, so 4:DT6 via service segment F1 and F2 hosted by node number 2 and node number 3 respectively. When the packet, we went over transit functionality for the SR aware service earlier. Now we are zooming into transit functionality for SR unaware service, which is node number 3 in this case. So node number 3, again, this is a snippet from the pseudocode from the SR service programming, that node number 3 will skip the application of the service function and will resubmit the packet for IPv6 transmission, which means that it implements the end functionality. So the packet is then sent towards node number 4 as shown on the figure on the right. Next slide, please. So basically what we covered is transit and end functionality. When ping to a SID, which is a service SID, we covered transit functionality and we covered the TE, how this work in all these cases. Now we would like to request working group review, and we would like the working group to adopt the document. Are there any questions? It's really good to see comments and questions.
Questions, please. Not seeing any questions. We're going to move on to IOAM. How are you? You'll be up as soon as Jim can get the slides up.
Thank you.
Thank you. Thank you, Savar.
Hello, can you hear me?
Hello. Yes, we can.
Okay.
And your cover slide is up right now.
Yes, okay. Yeah, I'm going to talk about a method to support in situ measurement in SRv6. Next slide, please. So a little bit background. So first, we have several proposal working group documents about SRv6 OEM. For example, the first one, SRv6 OEM, it outlines to use O flag and supporting some other OEM means. And we all know there are some other standards about active approaches, which are also applicable for SRv6 OEM. But here we are talking about particularly about the in situ OEM measurement in SRv6. Here we actually is about to support in situ OEM. There are already several existing proposals to support IOM in SRv6, like, for example, to encapsulate into the SRH-TLV. But the issue here is it introduces a big size overhead, which causes MTU concerns, and also it makes the processing more complicated and may introduce some forwarding delay and inaccuracy. So there's some issue about it. Also, we all know that due to the constraints of the RFC 8200, there are some difficulty to encapsulate IOM header in other locations of the IPv6 header. Next slide. So here we have the observation that for SRv6, the forwarding behavior is solely determined by the SRH only. And as long as two packets have having the same SRH, they will have the same forwarding behavior. So consequently, we can actually build an artificial packet to collect IOM data for other user packets, as long as they actually share the same SRH. And so this artificial packet, we call that probing packet. This will not have the encapsulation issues because it doesn't have any user payload. And also, we can allow the slow pass processing for this artificial packet, so that it doesn't consume the forwarding pass resource or doesn't have the performance concerns there. And also, you can see by using this probe packet, it actually can be considered an active method, but it achieves the in situ measurement effect as well. Next slide. So the proposal is very simple, and we can claim a bit, a flag bit from the SRH flag field. We call that T flag. So use that to indicate this is a dedicated SRv6 probe packet. And follow the SRH is UDP header. The destination port of the UDP header is used to code what type of IOM options is in the payload. So this is a scheme. Next slide. About operation, so the first node of the SR path will generate the probe packet. So if we intend to monitor some active user flows, we will copy the SRH from those flows and generate this probe packet. Then at each SR node on the path, if the node is capable of processing the TPs, then it will process the probe packet, and otherwise it just simply forward it. And the last node of the SR path will need to terminate that probe packet and export the IOM data to some collectors. As I just mentioned, actually we can support various different IOM options using the same method. We simply use a different UDP port number to differentiate them. Next slide. This scheme not only supports IOM for SRv6 by avoiding several of the encapsulation drawbacks. It can also support many other different applications. The first one is we can use this as an active method to measure the alternative paths for traffic engineering. If we have multiple candidate paths to the same destination, one is active but other are standby, so we can actually actively monitor them so to get their real-time performance. The next one is actually very easy to support the round-trip measurement with this. We can simply setting the last segment node to be the same as the first one, so the packet will be automatically routed back to the south, so we can get the round-trip time. Also, there's some algorithm to actually calculate a few number of passes that can cover all the nodes in the network. So then we can just plan this path to collect the data. Then we can gain the global visibility on all the segment nodes. Next slide. So the advantage of this scheme is that it's very simple and there's no need for control plane and a protocol for that. And it also only rely on the existing SR semantics, and it supports multiple useful applications. So since this is the first time presents this idea, and we'd like to hear more comments and suggestions from the working group, and welcome for any collaboration and contribution for that. So that's it. Thank you.
Okay, Greg, you had a question. Go ahead.
So if I understand correctly, what you introduced with this T flag, it's like at the end of the segment, it's a like bump in the wire because you want their fast path to punt it to their slower path processing.
It's not necessary. You can still do that in fast pass. I just mentioned it's possible to do that in slow pass.
Okay, so but this is a bump in the wire, so you still do something different from the plain forwarding on the packet.
Right. It's because that will be a dedicated probe packet. It's only process on that is to parse the UDP port, then understand which kind of payloads in it, and then extract data, required data to the IOM header. So that's processing. It's different from the normal user traffic.
Right. So thus, it does create additional computational load and might affect their forwarding of the user data, and thus it seems to become an attack vector.
Yeah, I'm not sure if you actually support to encapsulate IOM directly in user traffic, you will do the same thing, but it's on the user traffic. You will essentially delay the user traffic to support this actual processings. But here we can separate those two processes, so without delaying the user traffic.
Well, that kind of lost me, because you're saying you separated processing, at the same time you're saying that you are processing in a fast forwarding pipeline.
Right. So
okay,
so
let's take it to the let's
Yeah.
take it to the list. Thank you.
Okay, any other questions? Okay, Rakesh, you're up. I think. Or did I just skip one? Yeah, no, we did that. Yes, Rakesh, you're up.
No, Rakesh
Go
is
ahead.
up.
Go ahead, and you need to be expeditious. We did not give you as much time as we would have liked to. Rakesh, are you here?
I'm afraid he is busy in a different group.
Well, Yakov, you want to go now?
Okay with me.
Okay, Jim, bring up Yakov's slides. Let's go.
Not that one.
There.
There you go. Okay, hi
There
everyone.
it is.
Yeah, this is some new work. I'm emphasizing on this presentation the segment routing portion of this. Someone who is interested more in the delay sensitive portion can come to the talk I'm going to be giving in DECnet. Next slide, please. So what is the problem? The problem is time sensitive flows, that is packets that have to get in a expeditious way to their destination with a minimal delay, and I'm talking about really minimal delay. I'm talking about things which are more sensitive to time than some of the stuff they're talking about in DECnet. However, I want to compare myself to what DECnet is doing just before we get into the segment routing aspects. There are many mechanisms that have been proposed. Most of them fall on one of the bullets that I've mentioned here. For instance, it'll be very difficult to optimize them. They don't scale well. They have to be, if you want to optimize them, they have to be figured out ahead of time, what is called offline optimization. If you want to add a new flow, you have to re-optimize the whole system, et cetera, et cetera, et cetera. There's all sorts of reasons that there are problems with the existing mechanisms, and I want to propose a different mechanism. But from the point of view of this draft, all I'm proposing is the outside portion, that is what has to be done with the packet, rather than actually explain how it has to be optimized, and simulation results and all those will be reported elsewhere. So the main idea is I'm going to insert a stack data structure into the packet, similar to what is done in segment routing with different information, but it can be integrated with segment routing. Next slide, please. Okay, so what I'm assuming is we have some kind of router. I'm talking about the router from the point of view of having two functionalities. Number one, it does forwarding. That is, decides which output port a packet has to reach, and which, I'll call it a queue for now, for that output port, the packet has to be put into. And I have the scheduling logic, the scheduler. And the scheduler decides, in a simple case, which queue, using strict priority or a WFQ or something of that sort. Or in the DECnet for a way, what it does is it does some kind of computation of when a packet has to exit the router, and tries to make sure that the packet indeed is forwarded in time. So if you think about things from the point of view of forwarding and scheduling, without segment routing and TSN, what forwarding does, it decides which output port to use, and scheduling decides which packet of all those which are waiting for that output port should be transmitted, while with segment routing and TSN, you can think of it as forwarding decides where to send the packet, and scheduling decides when to send the packet. And that's an important thing which we're going to talk about in 2 slides, I think. Next slide, please. So what can be done without putting a stack into the packet? There are several mechanisms which have been thought of before. There's something called longest in system, which inserts a single time into the packet, the time that the packet was born, that is when it's injected into the network, and allows the routers along the way to prioritize the packets according to birth time. In other words, the earlier you were put into the system, the idea is that you've been waiting around for a long time. So we will try sending you before packets that entered the system, that is the network, later. Now, this is obviously suboptimal because you might have an early packet, a packet that was put into the network, but with a very loose delay budget, as compared to one which came in later, but has a very tight budget. Another mechanism which is frequently used is called EDF. Some of you might remember this from the ATM world. Earliest deadline first, you put, once again, a single time into the packet, and this packet is the packet's deadline, the overall deadline when it's supposed to exit the network, and you prioritize according to that. But that's not optimal either, because at each router along the way, the non-egress router, every router along the way, has a single number and cannot tell how much further after it leaves this particular router the packet has to go. So a router which is close to the beginning of the path really doesn't have very much information to work on. Next slide. So the proposal is to add a stack. That is a stack of local deadlines, which we can optimize. In other words, we're going to calculate when a packet should leave each particular router. And each router pops the top of its stack, does some kind of scheduling, which can be earliest deadline first or just in time or something I call PEDF. It doesn't really matter, but does something in order to prioritize that packet in order to make sure that the packet exits the router by the local deadline. As a matter of fact, if you want to do something funny, you can do a rather convoluted method which involves quantizing, which will actually reproduce 802.1 QBV, which is the gold standard in the TSN world that everyone says, oh, this gives absolute bounds. So you could even do that, but you can certainly do things which are more logical and perhaps better than that. Yes, I should note that the router is more complex than a typical router. That is, instead of having FIFO queues for each of the priorities for the output port, it has to have something more complicated. But however, I think it's less complicated than what QBV does with these time schedule gates that it defines. And I should note that, as I already mentioned, that there are several ways of computing the local deadlines. I give in the draft, SRTSN draft, a specific one, but there are many ones which have been discussed in the literature. Next slide. I don't see the next slide. Here we go. So what is SRTSN? Up to now, I've been talking about stack. Well, the idea basically is if I'm already adding a stack to the packet, why not add the segment routing stack as well? In which case, what I'm doing is I'm adding into the packet headers a stack of entries, one for each router to be traversed, each entry having 2 sub-entries, one a forwarding instruction, that is where to send the packet, which I'll use a segment routing instruction, and one which has a scheduling instruction, that is the local deadline that I was talking about before. So basically, what we have here is a stack of entries, each of which has a forwarding and scheduling portion. Each router along the way looks at the top of stack, knows where to forward, by when to forward, and then pops that with that entry. And the next router, of course, gets the packet with one less entry and looks at the top of stack and recurses until there's no more left. Now, since I'm talking about a DetNet or TSN kind of scenario, all of these routers are synced in time, so all these deadlines are directly comparable. I actually could have said that in the previous slide, but I just wanted to add it here. And of course, there may be other packets in the network which are not time sensitive, which are at a lower priority, and there can even be several priorities of time sensitive packets. And I have a mechanism for taking care of all of those using this SR-TSN stack. Next slide. This is just for those people who like the word network programming. I'm giving my own interpretation here. But if you think about it, what is the point of network programming? It's to do something like SDN, that is, to be able to programmatically set up your paths in the network, but doing it using the packet itself, so we can still maintain this idea of the packet finding its way through the network rather than have to configure a lot. So if you think about it, there's a progression where the simplest and inadequate kind of network programming is to simply have a single destination address in the packet, but that's only next hop forwarding. Segment routing, actually, it does a bit of network programming, but only for the forwarding portion of the router, not the scheduling. And SRTSN does both forwarding and scheduling network programming. And I put a note here, I don't want to take too much time, that there are obviously other things that routers can do, like rate limiting and things of that sort. However, anything which is not per router per packet, either being just per router but doesn't really care, it's the same for the whole flow or something like that, can be taken care of either by configuration or a single number in the packet rather than having to use the stack. So I'm emphasizing the forwarding and scheduling behavior. Next slide, please. Here's a simple example just to show you how this thing is going to work. I'm showing this example so you understand a little bit how this is just a one way of setting deadlines. But basically what we have here is a packet which is leaving a host that has to reach a host at the other end after 200 microseconds. And there are 4 routers in between. These routers are, the first one and the last one are connected with wireless links with a certain known delay. And yes, we have to know the delays to at least some accuracy between the routers. And I'm assuming someone does either some kind of time domain reflectometry or at very least a OEM delay, one-way delay measurement. And you can set it up so that each router knows when the packet has to leave it. And you can look at the draft to understand how I do that. And does a calculation by, if you look at the packet coming in, it doesn't have this header. In the next segment, the ingress router put this header on, and you can see the header sitting in there. It has 3 entries at the beginning, then 2 entries, then 1 entry. Each entry gives the forwarding information, then I have a semicolon, and then the scheduling information. And the schedules you can see above, just so you understand how to map these things. Obviously, since we're using segment routing, the ingress router adds this, and therefore actually the segment, the top of the stack when it first is entered is for the second router. If we wanted to use something more similar to source routing, we could only we could have one more when it comes in, and the host would do that. But in that case, the host would have to be synced up in time as well, which would make it a little bit complicated. Next slide. Okay, there's one thing I wanted to mention because it was on the list, and that is we had just now a talk about a moment ago about compression of headers. I do discuss on the list, and I'm going to have it in the next version of the draft, why it doesn't really take a lot of room for this stack. I decided not to talk about this in spring because segment routing people are used to this. In DetNet, I will discuss this. So what am I asking for from this working group? Since this draft talks about both segment routing and time sensitivity, it's not sure, it's not so clear where this should be discussed, whether in spring or in DetNet. And since we're going to be discussing how to optimize all this, there's also PCE kind of aspects. So I'd like to simply ask, is there interest in pursuing this work in this working group? And I would like to request the chairs of Spring, DetNet, and perhaps PCE, and I've been pointed towards RAW as well, to discuss or to coordinate between them where this work should progress, if at all. If you don't think it's a good idea, that's also completely valid. And I'll turn it back to the chairs.
Thank you, Yakov. We'll take questions. Just in terms of expressing interest, we're not going to conduct a poll right now. The best way to show interest is engage in discussion with Yakov on the spring list about the topic. Gaia, your question.
Can you hear me?
Yes, we can.
Okay. How does the draft update the SRv6 programming draft, or does it update?
I'm sorry, I have to say that I'm not sure exactly what that draft involves. This draft, I added the name segment routing simply because of the stack issues. I'm not necessarily actually using segment routing techniques. As a matter of fact, the mechanism I originally proposed uses indexes rather than full addresses. But I certainly am willing to learn more about the segment routing aspects and see how this could be integrated better.
Okay. Thank you.
Song.
I'm happy to see similar ideas raised again, because about 2 years ago, we have a similar document about this topic. We use segment to indicate expectation time of a packet to go output of a router, and with the explicit path. So I think it's a good idea, and I'm interested in this still. But I have to say the most difficult part about this idea is about it is tied to the queuing management mechanisms in the router, as you have mentioned, just like EDF or QBV or something like this. So I think this topic should be discussed more, especially the relationship of the protocol, just as segment routing, and the hardware mechanisms in the router. Thanks.
Okay, I'll address that really quickly. This draft talks about the mechanism of using a stack and unifying it with the segment routing stack, with a stack of deadlines. It doesn't discuss very much the precise mechanisms and how they have to be built. I'm not even sure that that is an IETF subject, but I'd be more than happy to talk about that, and maybe that would be the subject for a different draft.
Okay, thank you, Yakov, and thank you for being prompt. Oh, yeah. And we'll now move on to the presentations we skipped, and we actually have enough time for the presentations. We have my thanks to the other speakers for being prompt. Rakesh, you've got 10 minutes for each of your 2 talks, not the 5 minutes we said in the agenda.
Thank you, Joel. Sorry, I was presenting in MPLS, and apologies for being late. Hi, my name is Rakesh Gandhi, presenting the SRPM drafts on behalf of the authors listed. Next slide, please. So the agenda is we will look at the requirements and the scope of the draft, summary of the procedures and the next steps. Next slide, please. So the requirements in Ben, performance delay and loss measurement for links, as well as end-to-end SR paths, P2P and P2MP. Links can be physical, virtual, lag, or lag members, applicable to both SR-MPLS as well as SRv6 data planes. There are 3 modes: one-way, two-way, and round-trip delay, and as well as packet loss metrics computation. The goal is, with the spirit of segment routing, where the state is in the packet, like to avoid maintaining each test sessions on session reflector, avoid control protocol for signaling dynamic parameters. The scope of this draft is simple TWAMP. This is a new RFC in IPPM working group, RFC 8762, as well as stamp TLB extensions. RFC 8972 was just became RFC last month. And we have SR specific extensions for the stamp in IPPM working group. So this draft depends on the IPPM draft for SR extensions. And next slide, please. So we had the working group adoption poll, and we received a number of review comments. Many thanks to everyone you provided comments. So we have a new version with following updates. So draft status is informational. The terminology is updated to align with stamp terminology. There is a section added for the synthetic packet loss, which is as defined in stamp. There was discussions on the standalone direct loss measurement messages. So they are moved to a different draft. It's a standalone draft in IPPM working group and untied with SR. There was comment on IPv6 UDP test packet with 0 checksum. So we have removed that text in this version. We can work with working group on the appropriate text to add that, and some various editorial changes to address the review comments. So we don't believe there are any open items at this point. Next slide, please. Just to summarize the simple TWAM, the procedures for SR. So there is a young data model defines the provisioning aspects of it. There are some SR aspects of some examples that there is a UDP destination port defined with authentication mode and key. There is a delay measurement mode, one-way, two-way, or round trip, which timestamp format we want to use, or the packet loss if it's synthetic or direct loss. So this is just some examples of the provisioning aspects of it. And next slide, please.
Jim, we lost your... Jim's coming back. Just a second.
I'm back. Sorry, my network connection dropped. I'm back. Do I go to the next slide? Which slide do we want?
Yes, he wanted the next slide.
Okay,
same deck, next slide. You're not sharing your screen.
Hang on.
There. And now you're sharing your, there we are.
Got it?
Yeah.
Go ahead, Rakesh.
Yeah, so this is an example packet for test packet for links. It's using the destination UDP port that's configured. Sorry, lost again.
Jim, you lost the deck. You switched what you were presenting. There.
Yes. So again, it's a user configure the UDP destination port, IPTTL set to 1, and applicable to various links. Next slide, please. The test packet for the SRMPLS and SRv6 policy for SRMPLS is carrying the MPLS label stack. For SRv6, carrying the SRv6 segment list and also SRH for it. There is upper layer processing defined in network programming for the UDP header that's carried. The IPTTL is set to 255. There is a color-only destination steering. In this case, IPv4 destination address is set to 127 address. and IPv6 also corresponding back address as well. Next slide, please. For P2MP, the test packet is sent with 127 address for the P2MP MPLS with IPTTL set to 1 and the tree sheet as an example of the policy. Next slide, please. And the reflector test packet uses the information from the received test packet. Next slide, please. So this is where some of the extensions in IPPM come into the picture. So this is for the in-band measurements. So for one-way delay measurement is the existing stamp mode. In two-way, for links, there is a sub-TLV defined to send the in-band reply, and for end-to-end SR path, the sub-TLV, segment-less sub-TLV is defined for the in-band return path. And for the round-trip measurement, the packet carries both the forward and reverse direction path in the header itself. Next slide, please. So to handle the ECMP, there is sweeping mechanisms for IPv4 is 127 address. For IPv6 is the flow label. For IPv4 127 address is used. In order to avoid false positive, there is also a destination node address TLV to identify the actual node address. So when we get a reply, we know it's coming from the right intended destination. Next slide, please. So various PM metrics are used: minimum delay, maximum delay, average, and delay variance, and also for loss. There is a synthetic packet loss. There is direct measurement packet counters using the TLV that's defined in STAMP, and the session status succeeded or failed to know the measurement is active, also defined in the draft. Next slide, please. So welcome your comments and suggestions, and we are requesting working group adoption. I think we could look at the next set of slides in IPPM just to...
I'd like, Guyan's been waiting to ask a question, so I'd like to let him get his question and then you can go on.
Okay.
Guyan, go ahead.
Hi. Yes, can you hear me?
Yes.
Yes.
Okay. Hi, Rakesh. This draft was discussed fairly extensively on the spring work group. So I had a question. I see the draft was updated from standards track to informational. So that's good. I think one of the key points was that I think this draft, it seemed like it's mostly procedural of how to use stamp and clamp with segment routing. Were all the other updated? There was quite extensive number of comments, I think, by myself and Greg Mirsky. Were some of those other comments updated in the version 5?
Yes.
Okay.
And thanks again for your review comments. So we have addressed your comments. Please, in both, there are 2 drafts. One is in the, well, actually there were 4 drafts, simple TWAMP, as well as for the TWAMP Lite. So many comments were on the TWAMP Lite drafts. So there were 4 drafts. Today we are only talking about the 2 drafts, simple TWAMP in Spring and simple TWAMP in IPPM.
Right. Thank you. Thanks, Rakesh.
Thanks, Ken.
Okay, now we'll go to the next deck. Go ahead.
So since this draft in IPPM is a normative reference for the Spring draft, defines the extensions that Spring needs, and very specific to SR, we will go over those extensions. And next slide, please. So agenda is to look at the requirements and scope, the summary of the extensions and next steps. So same requirement in-band performance measurement for links and SR paths Goal is to avoid this, maintaining its test session on reflector and the control plane signaling. And the scope is the stamp extensions 8762 and 8972. Next slide, please. So again, Gan and Greg and many people who contributed to the review. Many thanks. We have updated the draft to address the comments, align the terminology. The direct measurement messages are moved to a new draft. It's a standalone draft, not tied to SR, based on the feedback from the working group. And it can have its own life cycle. Move the control code to return path TLV, and various editorials changes as suggested in the reviews. Next slide, please. So one TLV for the destination node address, as we mentioned, when we doing 127 address based probing, we need to identify the actual destination node to avoid false positives. So there is a TLV that carries the address. Next slide, please. There is a return path TLV defined for the in-band measurement for two-way modes. It has a control code and defines if need to send a reply in band or no reply, also return address or the SRMPLS label stack or SRV6 segment list or binding seed information. Next slide, please. So this discusses the usage of it. There were some comments on we had extensions, but it wasn't clear how are they being used, as the draft was split into two drafts. So this defines that control code is being used for the link delay measurement, where the reflector look at it and it will send reply in band on the same link where the test packet is received. Next slide, please. The return address is again, if we want to send a reply to a different destination address than the sender address, there is a return address also defined in the draft. Next slide. There is a return path segment list TLVs for SRMPLS and SRV6 and the binding seed as well. So for SR, paths are computed dynamically and topology can change. And the goal is, as mentioned, avoid the dynamic signaling and maintaining the states on the reflector. Could be tens of thousands of test sessions. So the return path information is carried in the packet itself by the sender. The next slide, please. So we are requesting the working group adoption in the IPPM working group for this one. We are presenting this draft as well in IPPM session on Friday. Welcome your comments and suggestions, and again, many thanks to all the reviewers who provided comments.
Thank you, Rakesh. Are there any questions on either of Rakesh's two presentations? Okay, then thank you very much. Krishna, I believe you're here for the Yang presentation?
Joel, there is one more draft on the, there is one liveness.
Oh.
Yeah.
Sorry.
I just brought it up.
That's
it's on
not, okay, that wasn't on the copy of the agenda I was looking at. Let's take it quickly.
No, it is there.
Okay, go ahead.
Thanks, Joel. Thanks, sir. Hi, everyone. My name is Rakesh Gandhi, presenting Enhanced PLM, Performance and Liveness Monitoring and Segment Routing Draft on behalf of the authors listed. Next slide, please. So agenda is we look at the requirements and scope, the history of the draft and updates, and the review of various procedures and next steps. And next slide, please. So requirements is again in-band performance, but this time liveness monitoring in SR networks for end-to-end SR paths applicable to SR MPLS and SRv6 data planes, and running a single protocol to simplify implementations and reduce development cost. Also for operators, simplify the deployment and reduce the operational complexity in the network. Goal is to no session reflector dependency. Again, the state is in the packet for SR. So the session reflector is not aware of the protocol, and also like to have very high scale and the faster detection interval. So the scope of this draft is the simple TWAM stamp RFC 8762 based implementations. The same packet format to leverage the timestamp fields at the same locations in the packets. Next slide, please. So this draft is a year old. We had presented the initial version in spring a year ago, and also was presented in MPLS working group. And we have made the updates. We'll look at the next slide, please. So we have updated terminology to align with STAMP terminology. We have added authentication mode. There is a capability, node capability added for the SRv6, also added synthetic packet loss, updated INR sections, as well as various editorial changes. We don't believe there are any open items at this point. Next slide, please. So a loopback mode is defined for SR policy as a test packet carrying the forward and reverse path. In case of SR policy, segment list is for each segment list of the SR policy, a test packet is sent with the segment list. Reflector just forwards the packet, is not aware of any monitoring happening. You can measure round trip delay as 2 timestamps on the sender side. Next slide, please. And when with the loopback mode, when it's used for network programming, the reflector not only just forwards the packet, but also timestamps the packet, and reply comes back to R1. So idea here is that this happens in the fast path, and you're getting not just liveness monitoring, but also the delay values because reflector adds the timestamp. So yeah, this is a combined liveness and delay in fast path. Next slide, please. So a similar provisioning model as SRPM, defining the which loopback mode, what timestamp label to use to enable the network programming, packet format, and various thresholds for the metrics. The next slide, please. So the example test packet formats, they are very similar to STAMP to take advantage of the hardware implementation of STAMP with the same timestamps. And the well-known timestamp offsets, for example, it's a byte offset 16 for unauthenticated and 32 for authenticated packets. And next slide, please. So in case of SRMPLS, there is a timestamp label carried by the packet that this is what tells the reflector to add the timestamp in the test packet. Next slide, please. So this is an example with the timestamp label. When the reflector sees it, it adds the timestamp 2 and it forwards the packet in fast path. There is no packets pointed. Next slide, please. Same thing with SRv6. In this case, there is an endpoint behavior defined for the SRv6 for this. Next slide, please. So there are various performance metric notifications. There is a liveness success. As soon as the packet comes back, you say session is up. When consecutive n number of packets drop, then session is down. There is a synthetic packet loss defined when X number of packets not received out of Y. There is a delay matrix notified when some m number of packets exceed the delay. So these are all provisional parameters and examples. And next slide, please. So welcome your comments and suggestions, and we are requesting Spring Working Group adoption for this draft. Thank you.
Any questions for presenter, for Rakesh on this? Not seeing any questions. Thank you, Rakesh. Discussion on the list. Krishna, are you here? If you're here, you need to unmute yourself. I thought I saw you on the list. Kamran, I guess you'll, thank you for offering to help. You can start.
Yeah, can you guys hear me? Okay.
Yes, we can.
Okay, I think Krishna is here and he's gonna probably he just joined, so he's gonna take over some part of this. So in the interest of time, I'll start and provide a quick context. So this is for presentation for BGP SRTE policy Yang operational model. As you can see, the title is operational model. Our goal is to go to configuration as well, but current revision is limited to operational model, and I'll provide a reason in few minutes. So in this model, basically, these slides have actually two slides which were cut and paste in the wrong set. So I'll talk through mostly verbally, and then ask Jim to go to slide 5, and Krishna takes over. So let me provide you a little bit of context. So originally we submitted BGPSR Yang draft many IETFs ago as a single draft that was like a catch-all draft that covered BGPSR aspect in general, BGPSR TE, as well as SRv6 BGP. Now, based on some input, internal input and other input, we realized that we need to break this into multiple documents. So we offshooted 3 documents out of this. One we call Spring BGP, one we call BGPSR, other we call BGPSRT, and the third one in the best for SRv6 services. So this document, specific document on the agenda right now is IDR BGP SRT Yang draft. So this draft, you can go to next slide, Jim. So this draft heavily depends on two drafts from IDR and Spring. One is of course BGP SRT in IDR, and other is a Spring SR policy architecture draft. On top of this, it's not listed here, but it also indirectly depends on Spring segment routing policy Yang draft, which itself is evolving. And once it goes to a good shape, we will align our draft with IETF Spring SR policy draft as well. In our draft currently, we augment base BGP model, and draft is NMDA compatible. Just to remind again, it's right now state only, but we will add the provisioning in the later revisions. And with that, I think I'll let Krishna take over, and you can go to slide 5. What we are covering in this draft is actually 2 things before I hand over to Krishna. One is BGP signal SR policy aspect, and other aspect is auto steering. And with that, I'll let Krishna take over slides onward.
Okay, thanks, Kamran. Can you hear me, everyone?
Yes, we can hear you.
Yeah. Okay. Sorry, I was on mute earlier. Okay. Thanks, Kamran. So I'll take over from here. So this draft is primarily defining the Yang modeling for the SR policy, dynamic SR policy, that's on-demand next hop SR policy, and the static SR policy. So in the dynamic SR policy, there is a template which defines what are the authorized colors and what is the color associated with it, and based on which BGP can initiate an SR policy and use that as a forwarding path when programming the route into the FIB. So the relevant configurations required for this creating a template, or the Yang modeling for that is defined in this draft, which is the authorized color, what is the color value, it's an unsigned in 32 value, and the policy state. When that policy gets created, the policy would have a state where the policy is associated with an IP address, that is the endpoint, the policy state, and the binding state associated with that policy, and whether the steering is enabled, disabled, and any ref counts associated with the policy. We can move to the next slide. So when the BGP initiates this SR policy, BGP associates that policy with the routing path for the BGP route path, and the existing BGP route path will be enhanced or augmented with additional information in addition to the existing BGP route path information, like the next hop and others. A new set of information would be associated with the BGP route path. That would be the associated color, the associated binding seed with that route path, and this particular draft defines the ANG modeling for this additional information that becomes part of the BGP routing path once the SR policy is defined for the BGP. So as part of this, we'll have ANG modeling to enhance the BGP route path with the color, endpoint, binding seed, and those would be defined in the ANG modeling. We can move to the next slide. That was the on-demand next hop ANG modeling for that, and there are two types of SR the SR policies. One is the dynamic on-demand next hop, which we just went over, and the other one is a static SR policy. So this particular slide is talking about ANG modeling for the static SR policy, which is the BGP pushed SR policies from controller into the BGP through a BGP address family. So in this case, BGP would be the one which is pushing the policies in from the controller into the BGP router, and this particular slide talks about the information that's the part of the SR policy that's pushed into the BGP as part of the static SR policy, and the information that's pushed into the policy are the distinguisher, the color, endpoint, preference. So all the required information is being defined. The ANG modeling has been defined in this in the draft, and they are being detailed in this slide. You can move to the next slide. This is a continuation of the slide where the SR policy, since it's a controller pushed SR policy into BGP, so controller itself gives all the required segment information, that is MPLS labels or the SRV sets, which form the forwarding path, and so that information is being defined as part of this draft, and they are detailed in this slide. We can move to the next slide. Yeah, so since the forwarding path, the SR forwarding path could be either MPLS or SRv6 or IPv4 nodes itself. So this particular draft defines all the relevant segment types, and this is a continuation of the earlier slide. So we can move to the next slide. Yeah, this is also continuation of the earlier slide. We can move to the next slide. I think that's pretty much it as part of this draft, and we have few modifications to do, so we are not yet actually asking for adoption. We want inputs and feedback from the reviewers on the call. Thank you so much.
Thank you, Krishna. Any questions for Krishna or Cameron on the Yang model operational material they just presented? Obviously, there's a whole series of steps we'll go through. They're refining it. We'll go through adoption. We'll need Yang doctors review, all of the usual things. But just for now, I hear no questions or comments. Okay, we have 6 minutes left, so I'll throw the floor open if there are any. Does anybody have any questions or comments about any aspects of today's session? If not, I'll give you 5 minutes of your day back. Not seeing any hands on the queue. So thank you, folks, for your time. We'll see you on Thursday, same time, same equivalent channel. Thank you.
Thank you.
Thank you, everyone.